Well, good morning. We have Mike Jensen with us this morning from sunny Florida. At least I hope it's sunny there. Mike contacted me a couple of weeks ago about getting some images of the comet in our hourly rental program using the 530 millimeter focal length Takahashi FSQ 106 and the full frame ASI 6200 color camera. And we captured about 45 frames. And as I looked at them, I thought these would also be a real good opportunity to do a short tutorial, we'll see how short, on how I do my Comet processing in a combination of PixInsight and Photoshop. So Mike is here to kind of observe and ask questions and give me somebody to talk to other than just a microphone. So good morning, Mike.
Good morning, and thanks for doing this. Appreciate it.
Oh, no problem. This should be a lot of fun. To start with, let's just take a quick look at what we've got. And I always like to just quickly blink through the image files before I start into the image integration to take out any obvious clinkers, because it doesn't do any good to have bad data included in with the good. So let's just quickly go to image integration or image inspection, pardon me, and blink. And we'll open the files that we collected for Mike, and I think there's around 45 of them here.
Yeah.
So these were captured the other morning, and we'll get those open in the blink tool, and we can just quickly look through. Typically what I would do if I find any bad frames in here is I'll just pull them out and move them to a rejects folder, and that gets them out of the workflow. Is kind of a quick and easy way to do that, just using this move file transfer button. So here we are in blink, and if we just quickly turn on the play, you can see that I was tracking on the stars, and we can see the comet's motion across the sky. And just looking at them real quickly, it looks like we've got a good set of data here, and I don't really see anything that we need to pull out, so we'll just leave it as it is. So we'll stop that and go ahead and close the blink. So the next step in the process is to run WBPP, and there's really nothing too special about the way I process WBPP for comets. I'll set it up in just kind of the normal fashion, and we'll just real quickly go through the setup, and then we'll jump to what the results look like. So to start with, let me reset this and clear all files out. And I know I'm going to want to clear this and make this auto. And we don't need some of these leftovers from before. So I always seem to load the lights first, and that way I know what filters and image lengths I need. So we'll go to the lights. And again, here's our 40-some files. So I would load those into the lights frame. And these have an exposure of 30 seconds. So I'll go to my darks, and I don't actually have darks of 30 seconds. I have 60 seconds, and I have those stored in my calibration data for the color camera, color darks. So we're going to load the 60-second darks. And then on the calibration frame, you'll see we've got a little warning here. And if I click on that, it's going to tell me the light frames differ from the master darks. But if I click on optimize master dark, then it will use the bias to create a master dark, and then it'll be happy. Although I do have to first load the bias frames. And again, that's under the color camera. Whoops, bias. There's some bias frames, and now it's happy. And then I would load, likewise load flats for the luminosity or luminance filter. And the other thing I do in calibration is I I have found setting a pedestal value of around 300 works well for my camera and my files and my imaging processes. If you don't have an output pedestal, you can get some odd kind of moire or moi pattern showing up in the images when it integrates. And a pedestal value of 300 seems to be sufficiently large enough to avoid that. So once that's all done, I would just hit run and let WBPP do its thing. And as you know, it will
And you
create a
don't
whole
use the
bunch.
cosmetic, do you use cosmetic correction at all?
No, I don't.
Okay.
That I've toyed with it and I haven't really seen an advantage to using it. So I haven't been. It just so that does let it run a little bit faster. Oh, since these are color images, I also need to tell it there's CFA and RGGB. So with that, I would hit run, and I've actually already done this. So let's go look at the results. I'll just double click here in the field, and we'll go to my swap files, Comet for Mike, and here's the master folder that it created. And there's 3 files in here. There's a master dark, a master flat, and a master light. And it's the master light that we're after. So let me double click on that. And there it is. And I'll just throw the screen stretch on it real quick to see what it looks like. And it's about what we expected. It's got some color cast, which is pretty typical. We can see that the comet was moving, and we saw that when we blinked through it. So we've got this nice streak of the comet streaking through those 45 frames. But the stars themselves look nice and tight. So at this point, I would process this kind of the way I would process any image and just ignore that we've got this blurry comet in the middle. So typically the first thing I would do is run a dynamic background extraction, and I have this saved instance with sample points already defined all the way around the perimeter. And unless there's something unusual that one of those points happens to fall on, I'll just open this up and click the execute checkbox. And that does a good job of neutralizing the background. And it'll also even out any gradient that we may have across the image. Generally, the next thing I would do is run blur exterminate. Well, actually, the next thing I would do is run the photos, spectrophotometric color calibration, which will sample the stars and adjust the color to give me what it feels is the correct star color. So I would run that on this image. And then usually I'll run blur exterminator. This doesn't really need much, but it'll tighten up the stars a little bit and give us a little bit better result. Since those take some time to run, I'm not actually going to run them as we're talking through here. The next thing I would do then is actually apply a stretch. And the way I do the stretch is kind of a lazy man's approach, I assume. I'll open up the screen transfer function dialog and also the histogram transformation. And we'll go ahead and apply this. And then what I'll do is grab these sliders and play with the overall intensity of the background and the stars. And since I'm really trying to develop an image for the stars, I want this to be a little on the dark side. That if this were a nebula, I wouldn't be looking at the brightness of the nebula, I'd be looking at the brightness of the stars. And then once I'm happy with that, you do the usual of grab the new instance triangle, drag it down to the bottom bar of the histogram transformation, and then click the square to apply that. And since it's now actually stretched, we don't need the screen preview stretch, so I can turn that off. And so now we have a stretched image. And then the last 2 things I would do typically is run blur exterminator noise exterminator to remove any noise. And then the final step is to run Star Exterminator to not only remove the stars, but also extract them to a separate file. And you do that by checking the Generate Star Image checkbox. And I always check the unscreened stars, which uses the reverse of a screen blending mode to remove the stars so that you can add them back with a screen blending mode. So I would run that. And once I do that, so as with a baking show, we'll pull the results out of the oven. This is what the base image looks like with the stars extracted. And what we really want are the stars. And so here's the star image extracted, and it's done a real nice clean job. So this becomes our star image. And at this point, I would save this star image as a 16-bit TIFF. And that's one of the two files that we need to put back together in Photoshop.
And you had no remnants of the comet in there after you extracted the stars out. Is that correct?
I don't see any. That's correct.
Yeah.
Sometimes a little bit of the halo will come through in the star image, but in this case, it did a real clean job and gave me just the stars without any interference from the comet. And where we're headed with this is we'll take this star image and then plus the comet image that we're going to produce, and we'll go into Photoshop to produce this final combination. It still needs a little bit of work on the yellow, green, and the tail here, but we'll have a layer of just the stars, and that's what we just looked at. And then we'll also have a layer of just the comet that we extract after aligning on the comet. And then we'll put them back together in Photoshop using that screen blending mode. So this is kind of our goal where we're headed to.
Okay.
So we have our stars. Now we have to create the comet image. And if you remember, the comet was moving relative to the star field. So we need to do a comet alignment. And fortunately, PixInsight has a real nice tool for that. I think you can do this also in Deep Sky Stacker, although I have not used Deep Sky Stacker for this, so I can't talk specifically about how they compare to one another. But go to the Comet Alignment tool or process in PixInsight. And the first thing we need to do is add files. So we need to pick what files do we want to add. And typically I will go back to my swap files for the Comet for Mike. And this time I'm going to go to the debayered. That before we looked at master and looked at the results. If I go to debayered, that's the original files that have been debayered, so they have color applied, but they're not registered yet. So open those, and you can see now we have the files listed here. And we want to do a couple things. We need to tell the Comet Alignment tool where the comet is in the first image and in the last image, and then also designate an output directory. And so typically I would create an output directory named something like star aligned. So, or comet aligned. You can see I've actually got, since I've already run it, we already have comet aligned. But I would choose that as the output directory. And then just double click on the first image in the list. And it will open up that comet image. And we can throw a screen stretch on it so we can see what we're doing. And then just zoom in. And you can see the crosshairs, find the comet and click on it. And you'll get the little circle showing that it recognized the comet. And then go to the last one in the list and do the same thing. Double click to open it. Put a quick screen stretch on it so we can see what we're doing. Zoom in to find the comet. Just click on the center of the comet. And so at this point, we've done everything we need to do to set this up to create a set of images that are comet aligned. And then you would just click on the Apply Global button, and it would go off and align each one of these according to where the comet is in the intermediate files. Now, as I mentioned, I've already done that. So let's just take a quick look with the images with the blank to look at those files. So let's go to the Comet Aligned, and we'll just open all of these. And if everything worked as it's supposed to, then as we blink through these, we should see the comet remain stationary and the star field move behind it. And I'm not sure why it's taking longer to open these than it did to open the, I guess because these are debaired. So these files are bigger because they have the 3 color channels instead of just a single one, perhaps. I'm not sure. No. Anyway, it's taking longer. And I believe the resulting files are larger. So here's our comet. And if I click the play button, watch the comet in the star field. And now the comet is staying stationary. And the stars are moving behind it. One of the things I did when I was capturing these was introduce a 30 to 60 second pause in between. The theory is that that should help with star removal. In practice, I don't know if it's really helping or not because there are still issues if you just try to integrate these. But we can see we've got the comet staying stationary and the stars moving. So comet alignment worked. The simplest next step is to just integrate these. So, you can just go to Process, Image Integration, and then choose the comet stacked images that we just created. So we would go to Add Files, Comet Aligned, add all of these, click OK, give it a and then hit the global apply. And even with pixel rejection, for instance, here I have, I've chosen Windsor Sigma clipping. Don't know if that's the best or the worst, but when you run this, it will go through and do an integration of these comet aligned images. Ideally, it will give you just the comet and it will reject the stars because they're moving. In practice, when I ran that, you wind up with something like this. So we still have the green color cast, and we know we can get rid of that. But you can see there's some pretty distinct streaks from the stars. So the pixel rejection didn't really get rid of all these. And it did carry along the green cast. If we just do a quick DBE to clean that up, we can see a little bit more what it looks like. Redo the screen stretch. So that's more neutral, but a lot of streaky noise in the background that's going to be hard to remove. The solution to that is to run these 44 files through some batch processes and apply some of the processes that we would normally apply to the whole group to each file individually before we stack it. And the way we do that is with a tool called an image container. So to get to an image container, you would right-click on the screen, choose Image Container, and it brings up this dialog box. So the first thing we would do is go to our Comet Aligned, and let's just imagine that we want to run Star Exterminator on each one of these. So I would select all of these and click Open. And then we would create an output directory. And we might give it a name, something like Comet aligned, star exterminated, or something so that we can keep track of it separate from all the other folders. So we'll just do that.
And Craig, is there an
Yep.
advantage of doing it this way versus going into the star exterminator and using the batch method inside of it?
I haven't used the batch method there, so I'm not sure.
Okay.
And I actually ran, if you look at the sequence, I actually ran this way. I ran a dynamic background extraction on each one of those, and then a blur exterminator on each one of them, and then star exterminator. So I actually did this 3 times to get to the star exterminator step. But the process is really the same. You create the image container that contains the list of images, and then an output folder where you want to save them, and then drag this down to a new instance. So this image container instance down here has all of these settings. And then you just, if you want to run star exterminator, you just grab star exterminator, drag it down to the image container, and it will go through and run star exterminator on each one of those images and save the result in this folder. And I actually did this 3 times. I did it once to apply a dynamic background extraction, once to apply blur exterminator, and then lastly to apply the star exterminator.
So you just drag the DBE or the blur exterminator over to the image container.
Yep.
Okay.
And it'll just real quickly run through and apply it iteratively to each one of those files. And on my computer with the ASI 6200 series, it takes about 30 seconds for star exterminator to run. So with 45 files, you're looking at 22 minutes, 25 minutes for that to run, which is why we're not running it live during the demonstration. But when you do that, let's just look at one of the sample files. So after blur exterminator and star exterminator, I was left with these files. If we just look at one of them. So now we've got a pretty clean looking file. Most of the artifacts are gone. And we know the Comet is aligned because we were running these on the Comet aligned set of files. So now we have 45 files that look like this with the Comet aligned and the stars removed. Now we can do that image integration on these cleaner files. And when we do that, we get this as the result. We still have some streaking, but it's much cleaner than it was before. And I'm mostly worried about streaking along the main part of the tail and the area where we have detail. Just for comparison, this was the previous version where we didn't run star exterminator on the individual subs, and this is what we got by running it on the individual subs. So this is still a linear image. So my next step would be to go through my usual process on this, which would start with stretching the image, and I'll do it the same way using the screen transfer function. And now I'm trying to find settings that give me good detail of the tail and a nice dark background. And a lot of the streaks, fortunately, are in areas that we just plain don't care about. Like all this area in the lower left has a fair amount of streaking, but we'll just turn that to a solid dark gray anyway, and get rid of all those. So, find a reasonable set of settings that look good. We'll pretend that looks good, and apply those settings. Turn off the screen stretch. And I think I'll run Noise Exterminator one more time on this. Russell's probably cringing as I do this, but we'll see if this gets rid of some of the streaking noise. And fortunately, blur, it runs pretty quickly. Yeah, I'd say that helped a little bit.
Yeah, it looks pretty good.
And we've got a couple distinct lines that we can deal with easily. So that gave us a pretty decent result. So at this point, and let's just go through the whole process. I'm going to go to File, Save As, and I'm going to go back to my Comet for Mike capture folder. And we'll save this as the Comet aligned DBE BXT SXT, and I'm saving it as a TIFF file. And I'm going to save this as a 16-bit TIFF. And I've had people wonder, if I'm not giving something up with a 16-bit TIFF versus a 32-bit. And because I've already stretched the image, it's already nonlinear, you don't really need to save it at a higher bit depth. And then I'll do the same thing with the stars. I'll do a save as, and I'll save these as just the stars extracted, and again, as a 16-bit TIFF. And with that, we should be done in PixInsight because we've now created a pretty clean comet image and a clean star image. So Mike, I know you have quite a bit of experience with Photoshop. I'll probably go through this a little more slowly than you would need me to.
Sure.
So this is kind of what we're headed for. And let's just get a fresh start. So the first thing I'll do is go to File, Scripts, Load Files into Stack. And what this does is it lets me load separate files as layers in Photoshop. And layers are really kind of the fundamental building block of an image in Photoshop. So the two we just saved are these two. I'll click OK, and that'll add them to the list. And then I'll click OK again to actually open those as two separate layers. So the first thing I want to do is I will put each layer into a group so that I can work on it somewhat independently with multiple adjustment layers inside that group that only affect what's inside that group. So we've got happen to have the comet on top. I can hit Control G, and that will insert that into a group. I'll double click on the name Group 1 and just change that to Comet to keep myself organized. And then I'm going to move this group by clicking and dragging down to the bottom of the layer stack. And we can see now we have the stars on top. I'll do the same thing, Control G, to put that into a group. Double click and change the name.
Photoshop has the same effect as like a folder approach in in Windows Explorer or Finder on a Mac.
Yes. And the nice thing about groups is you can kind of treat it as a layer from outside the group, but things that you do inside the group tend to stay inside the group, which is nice. Now, if you recall, when we created this star layer, we used the unscreen method in Star Exterminator. In Photoshop, we will put the stars back using the screen blending mode. And that blending mode is right here where it says pass through. And I'll click the drop down and change the blending mode to screen. And what screen does is basically a form of adding just the bright areas to the image below it. So it adds the stars back. And notice I did that on the group and not the layer itself. And I can turn those stars on and off. But I can also, for instance, add a hue saturation layer above the stars and inside that stars group. And if I increase the saturation, it increases the saturation of the stars, but it doesn't affect the comet underneath. So, that's not a bad looking image right there. And you could probably stop now because the stars do a pretty good job of disguising some of those linear artifacts that we had from the star streaks. But let's go ahead and take it a little bit further. And what I'm going to do is turn off the stars group so we can focus on just the stars or the comet layer. And I'll start by cleaning up some of these streaking artifacts. And I'll do that using the healing brush tool. The healing brush tool is a much more robust tool than the clone stamp because it actually uses some content-aware logic to blend the sample area over whatever it is you're trying to heal. And like the clone stamp tool, you can use it on its own layer. So I'll add a blank layer by clicking on the add layer icon at the bottom, create a new layer. So now we have a blank layer right on top of our comet layer. And let's target this streak right here. I'll use the left and right bracket keys to change the size of the brush. So I just use the left bracket to make it a little smaller. I'll choose a sample point and then drag over the thing I want to remove. And it's gone, but actually that healing step was done on a blank layer. And I can turn that blank layer off and you can see what was removed and turn it back on. The healing brush does a real nice job of blending the edges. So it's a very robust tool compared to the clone stamp.
Yeah, and this process of doing it on a blank, empty layer, there's a little bit of setup involved the first time. You can see in the upper part of your screen, you've got sample that says current and below, and you set up that once and you're good to go for as long as you're running Photoshop.
Yep. Yeah, and that that all leads to what's known as a non-destructive workflow. Non-destructive meaning that you don't really do anything that you can't undo. And for instance, here the healing I can undo just by turning that layer off or even deleting that layer if I make a complete mess of it. I can save this file as a Photoshop document, and when I come back to it, it's going to look just the same way with all the layers and settings intact. And I tend to work rather iteratively, so I'll do work on a file and then save it, see something that I want to change, and then I can just open it back up and go back to work on it.
Yeah. And many times when I'm working on things like this, I'll also make the base layer a smart object so that anything I do there can be tracked as well.
Yep. Yeah, anytime you feel compelled to do a stamp visible, and if you use Photoshop very much, you know what that is, the Shift Control Alternate E. It's very likely you can use a smart object instead and maintain that dynamic nature. So the color looks a little bit on the green side. So let's just throw a color adjustment layer, and that's on top of the healing layer. In general, you want your pixel bearing layers below the adjustment layers. And the healing layer is a pixel bearing layer because it actually has these spots where we applied healing. So by adding a color adjustment layer above that, I'm going to change the color appearance of everything below it. So we can you know, so, that doesn't look too bad for the comet. The background looks a little blue right now. So I'm going to add another levels adjustment layer, and I'm going to really target just the black layer and try to make it a nice neutral dark gray. And to guide me in that, I'm going to grab the color sampler tool, which is the third one down in that tool list. And I'll just click in an area that I want to be a nice neutral dark color. And if we look at the results, we're pretty dark at 849, and we're not really very neutral. Some of that could have been changed by the color balance. Yeah, it's still pretty dark. So let's try to get these to something around at least 15 to 20 RGB, and we want all three numbers to be equal. And we're targeting just the black levels. So in the levels adjustment layer, if we look in the properties panel, these are the settings for that layer. Let's go first to the red layer, and we'll brighten up the reds to about, let's say 16. And then we'll do the same thing with green. And when all three numbers are equal, that means the color is neutral. And then blue, same way. In this case, I'm using the lower slider to brighten the black level. If I was already higher than 16 and needed to darken it, then I would use the top slider to darken it down. So that gives us a nice dark kind of neutral color. And I think we've pretty well neutralized the color in the tail here. And for the most part, these streaks are not very prominent at all. I mean, we've got rid of the worst of them. And when we turn the stars on, they do a good job of completely disguising them. So we're probably a little bit bright here in the core. So we may want to darken this. Go back to the RGB. Maybe darken the brights just a little bit. And let's bump up the saturation of the comet. And turn the stars back on and see what we've got. So that's the basic process. Some additional things we can do. Mike mentioned turning this into a smart object. One advantage of that is then you can apply sharpening to it through a camera raw filter or directly with the sharpen tool. We can also do it with a unsharp mask, or we can use a high pass filter to create some sharpening. And just for fun, let's play with the high pass sharpening and see what we can bring out of the tail.
Yeah, that's one of the best tools I've used over the years to get some really nice detail.
Yeah, and a lot of times I will use it twice.
Yeah.
Once at a low setting to sharpen, and once at a high setting for enhancing local contrast. So to do that, there's lots of ways we could do that. I could grab just the base layer and work from that. We can work from a composite, and that's not a non-destructive way of doing it, but it's such a simple step. I'll do it anyway. I'm feeling bold. So let's do let's do it the right way. I'm going to duplicate this whole group by selecting the whole group and using Control-J to duplicate that group. Now we'll turn this group into a smart object by right-clicking and choose Convert to Smart Object. So now we have a smart object that we can apply filters to. And if we're going to do this twice, let's just go ahead and make a copy of it. And well, actually, we don't even need to make a copy, do we? Yeah, let's leave a copy there because we may want to use a mask. So
I found with high pass, making a copy is very valuable.
So let's do, let me zoom in and we'll do a kind of a low settings sharpening. So I'm on the smart object, filter, other, high pass. Let me change the blending mode first. It'll be easier to see if I change the blending mode to soft light, which is where we're going to end up. Filter, other, high pass. So now we're seeing the effects of that high pass filter. If I'm at a fairly low, and low would be for this camera somewhere in the usually 10 to 20 range, it mostly just sharpens. And I'm not seeing it bring out a whole lot more detail. At a high level in the 100, 200, 300, you can see it's starting to accentuate the tail. And that's somewhat the same effect that clarity would have in Lightroom. So let's go with something like this. And we can turn this layer off and on to see the effect. I like what it did to the tail. I'm not liking what it did to the comet itself. Fortunately, we can add a layer mask by clicking on this front-loading washer icon at the bottom, and that just adds this white thumbnail to the layer. That's the mask. And if we paint on the mask with black, black will hide the effect of this layer. So I'll make sure I have the layer mask thumbnail selected. I'll select the brush tool, which I can do with a B on the keyboard. I'll go to 100% opacity and flow. And then if I tap the D key, that will select the default colors of black and white. And then X will reverse them so that black's the foreground color. Now, any place I paint with black is going to hide the effect of that sharpening layer. And really, the only place I need to have it having an effect is on the tail itself. And you can see it even shows on the thumbnail where we have applied black. So now if I turn it off and on, it's only affecting the tail. And if you say, gosh, I like that, I want more of it, we can always just duplicate this layer and get even more. It would be interesting to compare this. What if we instead did a camera raw clarity? So let's select this smart object that we made the copy of earlier and go to filter, camera raw filter. And if you use Lightroom, these are the same tools that you would have available in Lightroom. So again, here's the tail. And if we just go to clarity and sometimes texture, I mean, that really does a nice job of bringing it out. And we can.
Texture does a lot when you're working with stars as well.
It does. Sometimes I'll even use a negative texture to kind of soften the stars. And then we'll pull the blacks down. I think the texture is bringing out those background streaks. So we'll go a little easy on the texture. But that really does a nice job on the tail. And when I click OK, it will update those settings And there's our smart object, before and after.
Nice.
I like the effect on the tail and some of the effect here in the secondary tail, the dust tail versus the ion tail. So again, let's use a mask, and I'll paint with black to hide that clarity effect where we really just want everything to be smooth, but still let it have its effect in the bright areas. Might mask it out a little bit here. And then turn the stars back on to see where we're at. And like I said, if I save this file at this point, it will save with all of these layers intact. You'll probably find if you approach it this way that the file is too big, since Photoshop has a 2 gigabyte file size limit on the native PSD files, or there's a 4 gigabyte limit on TIFF files. You may need to save this as a PSB, which is Photoshop's large document format. And you just do that by choosing File, Save As, and change the Save As type to a large document format, and give it a name, and then save it. And it will save it with all these layers and settings and everything intact. So what do you think, Mike?
Yeah, it's a nice image. The whole process was very, very nice and smooth. We should probably back up a little bit. When we talked originally, you talked about framing of the image and things like that. So some of our preliminary discussions included how to frame the image, and you had mentioned that you have the ability to show the client how that's going to be done. So this turned out really, really nice.
Yeah, and yeah, I was real pleased with the data you got. As I'm looking at it here on the screen, I think I'm seeing a little bit of blue cast in the background. And let's see what the color sampler says. No, not really.
It's pretty even.
It's pretty even. So yeah, I think that's pretty close to a finished image. Little bit of yellow greenish cast in the glow here. I think I'll just add a color adjustment. This may screw things up more than helping. See if we can neutralize that a little bit. I think that's a little better.
Yeah, many times I'll go into that hue saturation layer and make adjustments on each individual color channel for both saturation and luminance, and that's a good way to do it as well.
Yes, yeah, you can really target just the problematic color. So I think that gives us a good overall look at Comet processing. Just to make a quick review, to get to this point, we started in PixInsight and did just the usual WBPP sort of processing. And that gave us the image that we used to create the star image. So we had the base image with the stars, and then use Star Exterminator to extract the stars. Then we ran a series of steps on the Comet aligned images. We went through Comet alignment to create a set of Comet aligned images, and then used an image container in order to do things like dynamic background extraction and sharpening with blur exterminator, and then eventually star exterminator to create a set of starless comet aligned images that we could then integrate to get this image. And then the last thing we did was stretch and apply a little bit of basic processing to that before we saved it as a 16-bit TIFF. And that set us up for Photoshop. So any more thoughts or questions on this, Mike?
No, I think the idea of moving from PixInsight to do the Astro work into Photoshop is a really good approach. Even people who are not 100% comfortable in Photoshop can go in and even learn a little bit about the layer process, smart objects, what have you, and still be able to export out a nice looking image. So I like the approach, and you guys did a great job with the imaging. I appreciate it.
Oh, well, thank you. Yeah, of course, I've been using Photoshop for much longer than I've been doing astrophotography. So, Photoshop is kind of my happy place. And I just use PixInsight as a preprocessor to Photoshop. But I like that in Photoshop, you're working visually rather than numerically. That if I want to adjust colors or how the different pieces blend together, I can do it much more visually and more effectively, I feel, in Photoshop than I can in PixInsight. That may just be because that's the tool that I'm used to. And I know a lot of people grumble and gripe at the prospect of paying $10 a month to rent the software. And I was the same way. I still kind of grumbled and griped about that. But I think in reality, to me, it's the greatest deal around. For the price of a latte, you can have the industry standard image processing suite of both Photoshop and Lightroom. And I mean, that's puts it within reach of just about anybody with $10 a month versus the old days when you had to pay $600 to buy it.
I've never really understood the mindset behind all that griping, because they've already paid, in our book. I mean, we've got tens of thousands of dollars invested in telescopes and cameras and mounts and things like that. So $10 a month to process. It'll take almost 2 years to pay for that in PixInsight if you add up the monthly costs. So I think learning and investing in Photoshop is a great approach.
Yeah, I agree. So, Mike, I want to thank you for joining me here today. And I think this is a good point to stop the recording. And we've probably gone on for longer than most people are going to watch, but I hope enough people watch it to get some good out of this. If they have any questions, I can certainly drop them in the comments where this is posted on YouTube. And if you like the video and want to see more content like this, mention that in the comments, and be sure to like the video and subscribe to the channel. And with that, I want to wish everybody a great day today, and I hope you have an even better night tonight under a clear, dark sky. Thanks, Mike.
Thank you.